All right. What's happening? Here we go. Can't play the song that day. Don't want to get in trouble for copyright. So another one bites the dust. I feel like that was fitting for our last lesson of the year. But you know what? Here we go. Let's have some fun with this one. Surface area and volume of pyramids, cones, and spheres. We're gonna fit all three shapes into one day. Here we go. How are we gonna do it? I don't know. Let's talk to it. So surface area and volume of spheres and cones. If you talk about we're talking about pyramids as well. Pyramids. Two pyramids are very similar to prisms. Okay, they are similar to prisms in that they are a prism except with one base only. All right. Not only that, their lateral faces are all going to be triangles this time instead of rectangles. And just like prisms, pyramids are defined by their base. Okay. The unique shape is going to be their base. It's going to be obvious with the pyramid on what their base is because of the vertex of the pyramid being up here. Okay. You've seen pyramids before, ancient Egypt, all over the place in ancient Egypt, or not all over the place, but in ancient Egypt, there's the pyramid in Las Vegas. The Luxor Hotel is a pyramid as well. Okay. But there's other places I think too on the dollar bill, right? Or on one of the dollar bills or something. I don't know. I don't use cash, so I couldn't tell you. The altitude or height of the pyramid is the line that drops from the top of the pyramid and is perpendicular to its base. So it goes right through the middle. Okay. There's the slant height. The slant height is the height of our triangular face. All right, that's very important when we're finding our surface area. The height or altitude will come into play when we're finding the volume. Okay, so if I were to unpack a pyramid, it would look something like this if I had a square base. All right, L would be the slant height and B would be the length of a side. So to find in each of the four triangles, the area is B, 1/2 B times L. Well, how does that make sense? It's basically 1/2 base times height to find the area of each of these four, right? Well, if I do four of those, all right, four of these bases, four of these B's is just the perimeter of my base. Okay, so that's what our P stands for still. And then, here it is. And then capital B is the area of the base. So what I like to do is this. I like to write it like this. B plus PL over 2. And I want to put that in parentheses so you guys understand that, okay? That P times L is being divided by 2, not the area of the base, just these two, okay? So again, that's right here. I'm not going to do the 1/2. I'm going to do B plus PL over 2. I think that's easier to understand. P is the perimeter of my base, B is the area of the base, and L is our slant height. Here, so let's look at these two here. 7 is our slant height. I know it's hard to see. 4 would be this side here. All right. I said let's look at those two. Let's not. Let's do this one. So surface area of a pyramid is B plus PL over 2. Now, if I mess something up along the way, I apologize. Okay. So there was someone just outside of my apartment, and they were just yelling. And someone just, all I want's a smoothie. Everyone wants a smoothie. I don't know what that means. So our first step in these one is draw our base. Okay, just like with our prisms, we want to draw the base. The base is 16 and 16. All right, these are right angles. So this have a square. Find the perimeter of my base, my capital P, the perimeter of my base here. Okay, well, it's 16 times 4, which is 64. To find the capital B, the area of my base, it's 16 times 16. Whoa. Sorry, I got a little jumpy there, which is 256. Okay, so we got B and L, or P. Now we need to find our L. Okay, so we need to find the slant height. That's a capital I, apparently, slant height. And why do they use an L? H is usually used for height, right? L in slant height. S looks like a 5. Okay, so we use L. I don't know. It's weird. So what I'm going to do is I'm going to redraw one of my triangular faces like this. Okay, just like that, where this is a 16 and this was 10. To find the slant height is the height of our face. Okay, so if I draw this in, that would split this into 2 equal parts, so it's 8 and 8. Well, if I wanted to find x, holy buckets, wow, what would I do? I would use the Pythagorean theorem. This is a triple, but I mean, it's not a triple, it's part of a triple. It's 4 times 2 and 5 times 2, so it's 3 times 2, so x has to be 6. Okay, obviously you could do that by hand. 8 squared is 64, 10 squared is 100. 100 minus 64 gives me 36, which is 6. Okay, so now our third step, our final step, plug it in, plug it in, plug it in. Here we go, here we go. The surface area is B, 256, plus the perimeter of my base, 64, times 6 over 2. Plug it in, plug it in. Here we go. 64 times 3, or 64 times 6 divided by 2, plus 256 equals 448. And that's centimeters. That's what I thought, centimeters. You could heard the S. Centimeters squared. Let's talk about volume. Volume's a little bit easier. It's area of the base times the height divided by 3. Not the 1/3. I don't like the 1/3. All right. Area of the base times the height divided by 3. Okay. Area of the base. So I got my base right here. B. Area of this triangle, capital B. 8 times 14 divided by 2. 8 times 14 divided by 2. 56. So volume is 56 times 17. How do I know that that's my height? That's a great question. Thank you for asking. It's my height because it's perpendicular to my actual base. All right, this 25 here would be the slant height. It's not point. This segment right here would be our height. Okay, and then I have to divide that by 3, right? 56 times 17 divided by 3. Wow, it's a fraction. That's tough. That's okay. So you can write this as 317.33 units cubed. Sake of time, I'm not going to do this. All right. If I wanted to do that, do you see this little triangle that's in here? Okay. It's made with the 25 and the height of my shape. And then this would be 7, which is half of 14, which would make our height 24. It's a triple. But that's okay if you don't. That's okay. That's okay. It's okay. All right, so this one's a little bit different, but it's similar to a pyramid, okay? In a cone, I'm going to do pi RL plus pi r squared. See all this stuff? Like this is referring to a pyramid, okay? So L is our slant height, still, and R is the radius. If you look here, I know what R is, 4.7. This is the height of my cone. The slant height is actually X, so I do have to do the Pythagorean theorem here to solve for it. However, what was I going to say? I don't know. Holy buckets, my calculator's off. So let's do that. Go ahead. So I got X to be 11.41. So let's find our surface area. Pi R is 4.7 times L, which is 11.41, about, plus pi R squared, so 4.7 squared. Okay, 4.7 times 11.41. This would be 53.63 about pi, plus 22.09 pi, 53.63, which would give me a surface area of 75.72 pi feet squared. If I wanted the decimal, you would get, it's about 237.88 feet squared. All right? Depending on what the question asks, obviously. Cone is pretty similar to a pyramid again. It's pi r squared h divided by 3. So pi r squared h over 3 is our volume. Okay. If we were in class, I'd have this very cool, like these visuals where I was pouring water into solids, but obviously those are at school, so I don't have those just lying around. Even though you probably think I would, right? All right, so this is the height of this shape here. So this one's pretty straightforward. Pi times 3 squared times 6 over 3. Okay. This one I would actually have to find the height. All right. So this ends up being, what is that? 9, 9, 9, 2, 18 pi. Units cubed. Are we going to fit in the spheres in this whole video? Holy cow. Let's talk about sphere. Sphere is pretty not too bad. It's just 4 pi r squared. All right. It's 4 pi r squared. Okay. I mean, I could sit here and do a bunch of these 4 pi r squared, but I think you can figure this. You can do this. If I were to find the surface area of a sphere, if I was given a surface area and wanted the radius, I would just say 576 pi equals 4 pi r squared. Pi's would cancel out. Divided by 4. R squared would be 144, which would make R equal 12. Okay. This is pretty important. A sphere has a great circle of an area of this. All right. So what does that tell me? So great circles are, every sphere is made up of a bunch of different circles. And again, if we were in class, this would be a lot easier to show you the visual. So every sphere is made up with a lot of different circles within it, whether they're going vertically or horizontally like this. All right, there's a bunch of different circles drawn in there, and I wouldn't draw that on your paper. It's like how I like to think about it is if you have a baseball and you unstitch the baseball, okay, to go back to this one, it's like 4 circles being put together. That's why there's the 4 pi r squared. Well, a great circle within a sphere is the biggest circle in that sphere. Okay, meaning it's the largest one. It's the greatest. All right, it's the greatest one. It's the one with the biggest radius. Therefore, the radius of your great circle is equal to the radius of the sphere. So the radii are congruent. So if this is the area of the great circle, then I could use this to find my R. You could use that to find R. That was the most important part of that. To find the actual volume of a sphere, it's similar to cones and pyramids in that I'm dividing by 3. But this time, R is actually cubed. So how I like to think about this, I'm going to write it in my own way. Okay. I like to think about this as 4 pi r cubed over 3. That's how I like to think about it. And I think about it, okay, why is r cubed? Well, we're dealing with stuff. We're dealing with volume. Volume is in cubic units. Find the volume of a hemisphere. Remember, a hemisphere is half of a sphere. So why don't you pause the video and find the volume of this hemisphere. All right, so I showed my work for finding the volume of a sphere, all right, with a radius of 6, right? Okay, so I plugged that in for 6 cubed. I think it was 216 times 4 gives you 864. Divide that by 3, I get 288, okay? But I want the hemisphere, not the whole sphere. So all you need to do is divide that by 2 and get 144 pi centimeters cubed. Find what the hemi. Thing got a hemi? No, it's a hemisphere, actually. That's what you should say next time someone asks you that. No, I have a hemisphere. All right. That's it for today. That's it.